Good morning, everybody. I am Dr. S.S. Naidu, Assistant Professor in Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to discuss very important topic in probability and statistics. The first one is probability. What is meant by probability? Probable means the scope that may occur, the scope or the chance that may happen. It is called probability. Probability means the chance or occurrence, the scope of chance or occurrence of that event. Mathematically, this probability is defined for a number of possible outcomes, the total number of outcomes. Today, elaborately, we will discuss about probability. Probability, it means that it is a branch of mathematics that deals with the occurrence of a random event, that deals with the occurrence of a random event, how far it may happen. So, what is the maximum chance to happen that event? All these things we will discuss now. The value is expressed from 0 to 1. That's why the main condition of probability. Suppose E is a event of any event. Then the probability of that event is denoted by P of E. That P of E is called the probability of the given event happen. P of E. It is 0 less than or equal to probability of E less than or equal to 1. This is the main condition of probability. So the probability lies between 0 to 1. It may take 0, it may take 1. Beyond that, it doesn't go. So if it take the probability is 0, it is impossible event. If the probability is 1, it is a possible event, damn sure event, it is sure event. So the value is expressed from 0 to 1. Probability has been introduced in maths to predict how likely events are to happen. The meaning of probability is basically the extent to which something is likely to happen. This is the basic probability theory, which is also used in the probability distribution, where we will learn the possibility of outcomes for a random experiment. To find the probability of a single event to occur, first we should know the total number of possible outcomes. Here, suppose we are taking one event, then we should have idea that how many possible events are there for that given event. And we have to see the total number of events. Now we have to take the ratio between the possible outcomes to total number of events. Then it gives the mathematical idea of probability. So probability definition we can define like this. Probability is a measure of the likelihood of an event to occur or to happen. How much possibility is there? How likelihood is there to happen that event? It is our probability. For that chance, we are given some measure, mathematically. That is probability. Many events cannot be predicted with total certainty. We can predict only the chance of an event to occur, that is, how likely they are going to happen. Using it, probability can range from 0 to 1. Now only we have discussed here. 0 less than or equal to probability of E less than or equal to 1. So it ranges from 0 to 1, where 0 means the event to be an impossible one, and 1 indicates a certain event. If a probability is 0, it is impossible event. If probability is 1, it is certain event or sure event. So up to 10th class level, this topic and its basic definition is given there. Now, in a degree level and postgraduate level, we see utmost applications, deep applications of probability in many ways. So the important topic for the students, which explains all the basic concepts, are being discussed from class 10 onwards till now. The probability of all the events in a sample space adds up to 1. Previously we have discussed also, sum of all probabilities of that particular event should become 1. Maximum it should reach 1. For example, when we toss a coin, either we get head or tail. Only 2 possible outcomes are possible: coming head, coming tail, H or T. But when 2 coins are tossed, then there will be 4 possible outcomes. When 2 coins are tossed, then both may become head and head. One head, one tail may come. One tail, one head may come. Both tails may come. So these are the possible events. When we toss, we flip 2 coins at a time. Now let us see formula for probability with this example. The probability formula is defined as the possibility of an event to happen is equal to the ratio of the number of favorable outcomes and the total number of outcomes. So probability of event to happen, that is P of E, is equal to number of favorable outcomes divided by total number of outcomes. Now, depending on this knowledge, this theoretical knowledge, let us work out some examples. Suppose there are 6 pillows in a bed. Among them, 3 are red, 2 are yellow, and 1 is blue in color. What is the probability of picking a yellow pillow without seeing? Picking. Suppose on a bed 6 pillows are there. There are 3 are in red in color, 2 are in yellow in color, 1 is in blue in color. Now randomly we have to pick one pillow. It should be some yellow pillow. For that, let us analyze like this. The probability is equal to the number of yellow pillows in the bed divided by the total number of pillows. Here are how many possible events are there? 2. 2 yellow pillows are there. So 2 divided by total number of pillows 6. So 2 by 6. You can keep it in simplest form, 1 by 3. Like that, we have to apply our basic definition for the data of this sum. Now let us see one more sum. There is a container full of colored bottles, red, blue, green and orange. 4 colored bottles are there, red, blue, green and orange. Some of the bottles are picked out and displaced randomly. Sumit did this 1000 times. This 1000 times comes as a Bernoulli trials. This 1000 times we name it as Bernoulli trials. Now let us got we got the following results like this. Among those 100 times, number of blue bottles picked out 300, number of red bottles picked out 200, number of green bottles picked out 450, number of orange bottles 50 out of this 1000. So this total should become 1000. Let us check. Now each one is there. We can find probability for each one. Everyone is ready here. Now probability of blue bottles picked out is equal to 300 by 1000. You can write it as 0.3. Probability of red bottles picked out. Here number of blue bottles picked out. Everything is given. So probability of blue bottles picked out is equal to 300 divided by 1000. We can write it as 0.3. Probability of red bottles, number of possible events is 200 by total number of events 1000. You can write it as 0.2. Probability of green bottles, we can write it as P of G. It is 450 by 1000 is equal to 0.45. Probability of orange bottles picked out is equal to 50 by 1000. It is equal to 0.050. The total should become 1. Now let us analyze probability tree. The tree diagram helps to organize and visualize the different possible outcomes. Branches and ends of the tree. These are the branches and these are the ends of this tree are 2 main positions. Probability of each branch is written on the branch, whereas the ends are containing the final outcome. Here at the ends we write final outcome. Tree diagrams are used to figure out when to multiply and when to add. Now we can see a tree diagram for the coin like this. When we flip a coin, the probability for coming head is 1 by 2. It is 0.5. The probability for coming tail is 1 by 2. It is 0.5. So coming head we showed at this corner. Coming tail we have shown at this corner. So these two are outcomes. These are probabilities. So like that we can analyze this probability tree. Now let us see some types of probability. There are 3 major types of probabilities. Theoretical probability, experimental probability, axiomatic probability. These are the 3 types of major types of probabilities: theoretical probability, experimental probability, axiomatic probability. Now let us discuss one by one. Let us see theoretical probability. It is based on the possible chances of something to happen. The theoretical probability is mainly based on the reasoning behind probability. For example, if a coin is tossed, the theoretical probability of getting a head will be 1 by 2. The theoretical probability of getting a tail will be 1 by 2. Now, let us discuss second one, experimental probability. It is based on the basis of the observations of an experiment. Observations. The experimental probability can be calculated based on the number of possible outcomes by the total number of tries. It is the number of possible outcomes by the total number of trials. For example, if a coin is tossed 10 times and head is recorded 6 times, the experimental probability for heads is 6 by 10. Number of possible events by total number of events. Here, number of possible events of head coming is 6. So 6 by total number of events 10. 6 by 10. We can keep it in list form 3 by 5. 2 3s, 2 5s. Now let us see third one, axiomatic probability. What is axiomatic probability? In axiomatic probability, a set of rules or axioms are set which applies to all types. These axioms are set by Kolmogorov and are known as Kolmogorov's 3 axioms. Or previously we have discussed these Kolmogorov's 3 axioms. When the given 2 events A and B are independent, then P of A intersection B is equal to P of A into P of B. Like that, P of B intersection A is equal to P of B into P of A. These are Kolmogorov's principles. With the axiomatic approach to probability, first of all, what is axiom? It is mathematically approved statement. Axiom means it is a sentence or statement. It is a mathematical statement which is already approved, which is universally approved, accepted. That is called axiom. So, with the axiomatic approach to probability, the chances of occurrence or non-occurrence of the events can be quantified. What is this quantified? We are giving the number 1 by 2, 3 by 5. Like that we are giving numbers, no? That probability, for that probability, one numerical value we are giving, na? It is called, like that giving is called quantifying. The quantity, 1 by 2 is some quantity. 3 by 5 is some quantity. We are quantifying. The probability means that events, how far they can happen or exist, we are quantifying. The axiomatic probability lesson covers this concept in detail with the Kolmogorov's 3 rules along with various examples. Already in conditional probability we have discussed. This conditional probability is the likelihood of an event or outcome occurring based on the occurrence of a previous event or outcome. In conditional probability we have discussed there. So, let us see probability of an event. Assume an event E can occur in R ways out of a sum of n probable or possible equally likely ways, then the probability of happening of the event or its success is expressed as probability of that event P of E is equal to number of possible events by total number of events. Here it is R divided by N. So the probability that the event will not occur or known as its failure is expressed as P of E dash is equal to, so among the R successes, so failures are N minus R. So N minus R divided by N. It is equal to 1 minus R by N. So this R by N is nothing but P of E. We can write this as 1 minus, this R by N is what? This R by N is P of E. So P of E dash is equal to 1 minus P of E. Bring this minus P of E this side. Then what will happen? P of E plus P of E dash is equal to 1. P of E plus P of E dash is equal to 1. So E dash represents that the event will not occur. That's why it is becoming P of E plus P of E dash is equal to 1. This means that the total of all the probabilities in any random test or experiment is equal to 1. Now what are equally likely events? When the events have the same theoretical probability of happening. When the events have the same theoretical probability of happening, then they are called equally likely events. The results of a sample space are called equally likely if all of them have the same probability of occurring. So equally likely if all of them have the same probability of occurring. For example, if you throw a die, then the probability of getting 1 is 1 by 6. Similarly for 2, 1 by 6. For 3, 1 by 6. For 4, 1 by 6. Getting for 5, 1 by 6. Getting for 6, 1 by 6. 1 by 6, 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 1 by 6. Same, equally likely. So for all of them, we are getting probability 1 by 6. Hence, the following are some examples of equally likely events when throwing a die. Now, getting 3 and 5 and throwing a die. Getting an even number and an odd number on a die. Getting 1, 2, 3 and rolling a die are equally likely events, since the probabilities of each event are same. Here for even number 2, 4, 6. So how many are there? 3. So 3 by total number 6. 3 by 6 is 1 by 2. Getting odd number 1, 2, 3 are there. 3 numbers are there. 3 by 6 it is 1 by 2. So 1 by 2, 1 by 2 equal. These so getting even and odd number, they also come under equally likely events. Now let us see complementary events. Here now only we have discussed. For P of E, complementary event is P of E dash. For Phi of E dash, complementary event is P of E. The possibility that there will be only two outcomes, which states that an event will occur or not. Like a person will come or not, come to your house, getting a job or not getting a job, etc. are examples of complementary events. Basically, the complement of an event occurring in the exact opposite, that the probability of it is not occurring. Some more examples we can see. Now let us discuss theory of probability. Probability theory had its root in the 16th century when J. Cardano, an Italian mathematician and physician, addressed the first work on the topic, the book on games of chance. The book on games of chance. In that, very elaborately all these things had been discussed. After its inception, after its starting point, the knowledge of probability has brought to the attention of great mathematicians. Thus, probability theory is the branch of mathematics that deals with the possibility of the happening of events. Although there are many distinct probability interpretations, probability theory interprets the concept precisely by expressing it through a set of axioms or hypotheses. What is axiom? Mathematically accepted, approved statement. Axiom means mathematically, universally accepted statement. Hypothesis means given thing. These hypotheses help from the probability in terms of possibility space, which allows a measure holding values between 0 and 1. That's why 0 less than or equal to probability of E less than or equal to 1. This is so many times I am writing this condition. This is called probability condition. This is known as the probability measure to a set of possible outcomes of the sample space. Now, let us define probability density function. The probability density function is the probability function. Basically, it is a probability function which is represented for the density of a continuous random variable lying between a certain range of values. Previously, while we were discussing about discrete random variable and continuous random variable, we have discussed about this topic. For discrete random variable, what we are describing, that probability function is known as probability mass function. And for a continuous random variable, what we are discussing, the probability function is known as probability density function. This probability density function is for the density of continuous random variable lying between a certain range of values. Probability density function explains the normal distribution and how mean and deviation exists. The standard normal distribution, when do we say it is standard normal distribution? So previously so many times we have discussed the when arithmetic mean mu is equal to 0, standard deviation sigma is equal to 1, we say that deviation is called standard normal distribution. The distribution is called standard normal distribution. So the standard normal distribution is used to create a database or statistics which are often used in science to represent the real valued variables whose distribution is not known. Now, let us see the key terminology, the terms and the terminology which we frequently use in probability and their basic definitions with some reliable examples. Sample space. What is the sample space? It is the set of all the possible outcomes to occur in any trial. Set of all the possible outcomes to occur in any trial is called sample space. See, as an example, we can see when we toss a coin, sample space S is equal to set H for a head, T for tail. Some S is equal to some H comma T. That S is called sample space. Suppose when we roll a die, a sample space S is equal to set 1, 2, 3, 4, 5, 6. This is the sample space for when we roll a die. Now, let us see sample point. What is sample point? It is one of the possible results. Among those possible results, randomly if you pick up any one result, it is some sample point. Suppose, if we see example, in a deck of cards, 4 of hearts is a sample point. The queen of clubs is a sample point. Like that we can see. Now let us see what is experiment or trial. These are all terminology of probability. Experiment or trial, what is that? A series of actions where the outcomes are always uncertain. For example, the tossing of a coin, selecting a card from a deck of cards. How many cards are there? 54 cards are there. 13 fours, 52 cards are there in a deck of 52 cards. Throwing a dice is a sample, is an experiment. Now, what is event? It is a single outcome of an experiment. Getting a heads while tossing a coin is an event. Like that, getting a tail is also an event. Next, outcome. What is outcome? What is coming out? Possible result of a trial or experiment. For example, tail is a possible outcome when a coin is tossed. That is outcome. Next, what is complementary event? If one happens, other doesn't happen. The non-happening event. The complement of an event A is the event not A. That is A complement, A dash. For example, in a standard 52 card deck, suppose A you are taking as draw a heart. Then A dash will be don't draw a heart. Just quite possible, opposite to that. Next, impossible event. What is impossible event? The event cannot happen. That is called impossible event. For that, in that time, P of E is equal to impossible event means P of E is equal to 0. This is impossible event. For example, in tossing a coin, impossible to get both head and tail at the same time. Not possible. Impossible. Now let us see some applications of probability. Probability has a wide variety of applications in real life. Some of the common applications which we see in our everyday life while checking the results of the following events. Choosing a card from the deck of cards, flipping a coin, throwing a dice in the air, pulling a red ball out of a bucket of red and white balls, winning a lucky draw. All these applications of probability in our daily life. Now let us see other major applications of probability. It is used for risk assessment and modeling in various industries, whether forecasting or prediction of weather changes, probability of a team winning in a sport based on players and strength of team. In the share market, chances of getting the hike of share prices. We can use our probability scientifically there, and we can find the probability of possible event, the concerned events, and scientifically, mathematically. Now let us see some numerical problems. Find the probability of getting 3 on rolling a die. Here, what is the sample space as? Set 1, 2, 3, 4, 5, 6. Here, the total number of outcomes, number of S is equal to 6. Let A be the event of getting 3. So, number of favorable outcomes, how many times the 3 will come? 1 time. So, if N of A is equal to 1. Then, what is the probability of getting 3? Number of possible events by total number of events, that is 1 by 6. Like that, see one more example. Draw a random card from a pack of cards. What is the probability that the card drawn is a face card? In that, we have to know what is a face card. That king, queen, jack, all these are called face cards. Here, a standard deck has 52 cards. Total number of outcomes here is evidently 52. Deck has 52 cards. N of S is equal to 52. Let E be the event of drawing a face card. So, number of favorable events. N of E is equal to 4 by 3. Why? Here, face cards are 4 categories. Clubs, hearts, diamonds, and hearts. So 4 types are there. They are called face cards. Among those, in every set of 4, three face cards will be there. Jack, king, queen. Ace or jack, both are same. Yeah, ace or jack, king, queen. These 3 are called face cards. Like that, these 3 face cards will be there in all 4 sets. That's why 4 into 3. totally 12 face cards will be there. Totally 4 by 3, 12 face cards will be there. In hearts, 3 face cards will be there. In clubs, 3 face cards will be there. Like that. In remaining 2, 3 will be there. Like that, 4 by 3, 12 face cards will be there. So, the probability is the ratio of number of favorable outcomes to the total number of outcomes. So, P of E is equal to N of E by N of S. N of E, total number of face cards, 4 by 3, 12. So, 12 divided by N of S, total number of cards, 52. So, 12 by 15 to 2. If we keep it in a simplest form, it is 3 by 13. 4 table, 4 3s, 4 13s. So, probability of the card drawn is a face card is becoming 3 by 13. Now, let us see one more example. A vessel contains 4 blue balls, 5 red balls, and 11 white balls. Total how much? 4 plus 5, 9 plus 11, 12. 9 plus 11, totally 20 balls are there. If 3 balls are drawn from the vessel at random, without seeing, from that 3 balls are drawn like this, random experiment, among those 20 balls. What is the probability that the first ball is red, the second ball is blue, and the third ball is white? Here, very carefully we have to analyze. Here what is given? The probability to get the first ball is red, or the first event is P of red, which comes first, is equal to total number of red balls 5 divided by total number of balls 20. It is 5 by 20. Since we have drawn a ball for the first event to occur, then the number of possibilities left for the second event to occur is 20 minus 1. Why minus 1? One ball already you picked out of. So how many remaining balls will be there? 20 minus 1, 19. Now in denominator, now onwards, now we have to take 19. So hence the probability of getting the second ball as blue or the second is P of second ball as blue is equal to how many blue balls are there? 4 divided by total number of balls 19. Don't write 20, because in first event one ball is already picked it out. 19 total, now 9 total number of balls are 19 only. That's why now you have to write 4 by 19. Again with the first and second event occurring, the number of possibilities left for the third event is 19 minus 1 now, 18. And the probability of the third ball is white. The third event is, how many number of white balls are there? 11 divided by, now how many balls are left over? 18. So it is 11 by 18. Therefore, the probability is 5 by 20 into 4 by 19 into 11 by 18. It is 44 divided by 1368. After simplification, it comes as 0.032. Or simply we can express it as P is equal to probability is equal to 3.2%. Now let us see one more interesting example. if two dice are rolled, find the probability that the sum is equal to 1, equal to 4, less than 13. Here, two dice are rolled. So total number of outcomes are 6 by 6, 36. N of S is equal to 36. To find the probability that the sum is equal to 1, we have to first determine the sample space S of two dice as like this. What are the possible outcomes? 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. 3 1, 3 2, 3 3, 3 4, 3 5, 3 6. 4 1, 4 2, 4 3, 4 4, 4 5, 4 6. 5 1, 5 2, 5 3, 5 4, 5 5, 5 6. 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. These are the possible. So, number of S is equal to 6 by 6. 6 into 6, it is 36. Let E be the event. Now, let us answer first one. Sum equal to 1. Sum equal to 1. No, there is no possibility. Suppose on first one 1 comes, on second one at least 1 is there. 0 is not possible. Then the least possibility is 1 plus 1 2. But the least sum equal to is 2. So there is no possibility sum equal to 1. It is impossible. So it is impossible event. The number of E is equal to 0. Number of S is equal to 36. 0 by 36 is 0. It is impossible event. First one. Its probability is 0. Now let us see second one. Let A be the event of getting the sum of numbers on dice equal to 4. Here 4 possible outcomes are there. What are they? 1 3, 2 2. Sorry, 3 possible outcomes are there. They are 1 3, 2 2, 3 1. So number of A is equal to 3. Hence, possible outcomes are N of A by N of S is equal to 3 by 36 is equal to 1 by 12. So, let us see the recapitulation part. Once, let us see the basic probability terms and definition once again. This is sample space means the set of all the possible outcomes to occur in any trial. Like, for example, we can take tossing a coin. Sample space S is equal to set H comma T. H for head, T for tail. When we roll a die, sample space S is equal to set 1, 2, 3, 4, 5, 6. This is a sample space. Now, what is sample point? It is one of the possible results. For example, in a deck of cards, 4 of hearts is a sample point. The queen of clubs is a sample point. Like that, experiment or trial, a series of actions where the outcomes are always uncertain. The tossing of a coin, selecting a card from a deck of cards, throwing a dice is best example for experiment or a trial. What is event? It is a single outcome of an experiment. Getting head while tossing a coin is an event. What is outcome? The possible result of a trial or experiment is called outcome. For example, Tail is a possible outcome when a coin is tossed. Complementary event. What is complementary event? The non-happening events. The complement of an event A is the event, then for that non-complement is complementary event is not A. It is known as A dash. Yeah. For example, in a standard 52 card deck, suppose if you take A as drawing a heart, then A dash is don't draw a heart. Now, impossible event. What is impossible event? If P of E is equal to 0, it is called impossible event. The event cannot happen. In tossing a coin, impossible to get both head and tail at the same time. It is very, very impossible. There is no chance to occur there. That's why probability of E is equal to 0. That's why we can elaborately discuss probability like this. Thank you. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.